Okay then, so welcome to the Walking Talking mock for your Easter half term. Before we go any further, one thing that I'm going to tell you must do. Every question that I complete, you must also complete. Okay? If you don't understand what I'm talking about, what you must do is you must put a little star next to any question that you think, I've got no idea what he's talked about then. That way, myself and the other teachers can put these papers together and we can look at the ones that as a class we're not liking and then we can concentrate on those. Okay? Okay, the first question we've got is an exchange rates question. So I'm going to go and draw my arrows on here straight away. So times by 1.52 and then divide by 1.52 to turn it back. Now, we're used to seeing these come up in calculator papers, and that's not the case in this question. So we're going to have to use a non-calculator method. So if I'm to change £300 into dollars, I must do 300 times by 1.52. Now, I obviously don't know the answer to that, and you're not expected to know the answer to that either. But what I can do is times by £100 first. So times that by 1.52 would give me $152. Now that's for £100, so what I need to do now is times this by 3, so that just means I need to times this answer by 3. And again, I don't know what that answer is, so I'm just going to set it up like this, and then I'm going to do 2 times by 3, and that's 6. Then I'm going to do 5 times by the 3, that's 15, so I write down the unit, which is a 5, and carry the 10. And then I'm going to do 1 times by 3, but then I'm going to add on this 1, so that gives me a total of 4. So my answer was $456. The next question says, it says, Adrian wants to exchange $558 into pounds. Estimate how many pounds Adrian is likely to receive. Okay, so it's an estimate, and look, they've even put that word there, estimate, in bold. I know that the real conversion would be 585 divided by 1.52. Okay, sorry, let me make that look a bit better. So what I need to do now is change these for more reasonable numbers. So I'm going to change the 585 into 600, and I'm going to change the 1.52 into 2. Okay, this is purely just an estimate, doesn't need to be spot on, and half of 600 would be £300. Okay, with this question it says 4 centimetres on the map is the route from Edinburgh to Dundee. The actual journey is 100 kilometres. Now when it says calculate the scale of the map, giving your answer in the form 1 dot dot, this means because they haven't put any units here, they want these to be in the same units. So the common mistake here is that you're going to say 4 centimetres is equal to 100 kilometres. And then you'd say maybe halve both of those, so 2 centimetres is equal to 50 kilometres. And then 1 centimetre is equal to 25 kilometres. If I wrote that up here, 25 kilometres, I wouldn't get both marks. I'd certainly get 1, but I wouldn't get 2. And the reason why is that's in different units, okay? So what I need to do now is I need to change the kilometres into centimetres. So I'm going to take this in 2 steps. So I'm going to say 1 centimetre is equal to 25,000 metres. That's what the K stands for. K is kilometres. The K stands for 1,000. And then I'm going to change metres into centimetres. So that is going to become 1 centimetre is equal to 25,000 would still be the metres. But then I'm going to add on 2 more zeros because there are 100 centimetres in a metre. Okay, so my answer would be 1 centimetre is equivalent to, what's that, 2 million by the looks of it? 2,500,000. Okay. The next question says the journey from Edinburgh to Dundee takes 2.5 hours. Now it doesn't say that, does it? I've just read it as that because I'm sort of thinking ahead. It's 2 hours and 30 minutes. They always go for a trick like this. You need to change that into minutes and hours. So I'm going to change that straight away to what I said the first time. Say 2.5 hours. Or I could say 2.5 hours. Calculate the average speed of this journey. Okay, so I'll do my triangle. So distance, speed is equal to distance divided by time. Cover up the s because it wants me to find the average speed, so covering up the s gives me d over t. So my speed is going to equal the distance, which was 100 kilometers, and it took 2.5 hours. So divide that by 2.5. Now, I don't know the answer to that, and I don't like dividing by decimals. So I'm going to times top and bottom by 10 to get rid of it. In fact, actually, no, I'm not. I've changed my mind. I'm going to times by 4. Because if I times that by 4, 2.5, 5, then with 2.5 added onto it would be 7.5, then 10. Okay? So that's now 10. This would now be 400. And then 400 divided by 10 is 40 kilometers an hour. If you didn't like the way I did it just then, you could have done exactly what I said before, which was times it by 10. That would have given me 1,000 over 25, but nothing was really filling me with joy about having to do 25s into 1,000. So 25, 50, 75, 100, that's 4. And then you're going to have to repeat that 10 times, so 40 again, okay? So they both give the same answer.
Okay, the next question has got two principles all tied into one. Okay, the first thing that I'm spotting here are these arrows here and here. That means these lines are parallel. So we should be either seeing Z letters here, we can see a C letter there. We can't see our F letter because they don't, it doesn't go through both lines. But you usually see Fs and you can sometimes see Xs as well. But again, that's when two of the lines are overlapping. So I'm going to go back to that Z that I just saw. And I know that Z angles, real name for that is alternate angles. I know Z angles are identical, so I know that is 76. The next thing I'm going to do is I am going to notice these dashes here. Now, we've talked about those in lessons before as like angry birds. So we said treat them like the eyebrows on the Angry Birds. What comes underneath eyebrows? Eyes. So we have an eyeball there and an eyeball there. That means this must also be 76 degrees. Okay? Next thing I'm noticing is I've got a triangle, and angles in a triangle add up to 180. So if I do 76 add 76, I get 6 add 6 is 12, 7 add 7 is 14, add the 1 is 15. I get 152, but then I need to do 180 because of angles in a triangle add to 180, and I want to take away the 152. Be careful here, 0 take away 2 is not 2, it's minus 2, so we need to borrow 1 because we can't have minuses. 10 take away 2 is 8, 7 take away 5 is 2, 1 take away 1 is 0. So my angle here is 28 degrees. Final bit that I need to do. I know here angles on a straight line add up to 180, so I now need to do 180 degrees, take away the 28 degrees, and 0 take away 8 can't do because it goes to negative. 10 take away 8 is 2. 7 take away 2 is 5. 1 take away nothing is 1. So my angle here for x is 152. Now, the problem with my solution at the moment is I have not done what they've put really clearly in bold. Okay, so everything that I've just said, I need to actually write down. So the first thing I did was I found out this angle here, which if I use the letters, I've gone from letter E to C to then B, or B to C, then E. It doesn't matter as long as the C is in the middle. So I'm going to say BCE was 76 degrees because of Z angles, but I'm going to put its proper name in, okay? And so when I see Z, I think A to Z, and that helps me remember that its alternate angles, okay, are equal. The next thing I'm going to say is angle CEB, so E being in the middle means that top one here, that's what this one means, is also 76, was 76, and that's because of isosceles triangles. So because isosceles triangles have two equal angles. The next thing I worked out was angle B. So angle B, I'm going to say CBE. I'm going to say CBE, so that's this angle here, is this angle here, was 28 degrees because, and I use angles in a triangle equal 180 for that. Angles in a triangle add to 180 degrees. Okay, and then finally my angle x, so missing angle x, was 152 degrees because angles on a straight line add to 180. Okay, so 6 marks there. Okay, and I think with all those calculations I've got by the side, it's very, very obvious as to what I was doing. Okay, and with this question, it'd be a good idea to get your protractor, ideally a 360 protractor, because it makes drawing bearings very, very easy. Now, if I'm to go and draw this angle here, I'm measuring clockwise, 0 should be on here, and then I'm measuring, obviously that would be 180 halfway, and then a little bit more on to get this line coming here, but you need to physically go and measure that, okay? So here's where my new place is. It says the bearing of a Rayton from cum is there. So I'm going to say here, this is Rayton, and I'm going to draw a north line straight up. And then I'd take my protractor, and I'd physically go and measure what this angle here is, okay? So that's one way of doing it. The other way of doing it is trying to use just angle formulae. So I know this angle is 235. I know that angles at a point add up to 360. So I could say 360 take away 235 and work that out. So that's going to give me 5, 2, 1. This would be 125. And then this is parallel lines. So parallel lines, these are what we call C angles. C angles add to 180. So if I do 180, take away 125, I would get, what would I get? I get 55. But that's not the easiest way of doing it. But I've made one massive error here. My bearing must always be in 3 digits, so it would be 055 for 1. But you could do it drawing, and it doesn't matter where you physically go and draw it on the line, because it doesn't tell me how far away it is, it's just on that bearing. So this angle, if I move this line here up to here, it should still be 55, it should still be 55 anywhere on it. Using a protractor is probably the easier way to go around this. For the next part of the question, I'm going to start it over on the next page. So if you'd like to turn over, and we'll start working through that one. Okay, so it says machine A makes 180 plastic spoons, and machine B makes 240 plastic forks, and both within an hour. It says both machines start their production on Monday at 9 AM. Both machines are stopped for maintenance after 450 spoons have been produced. Okay, so I can get an easy mark by here. So I'm looking for the spoons, so I'm looking for this one here, and I'm after 450 spoons. So I know at Monday, so I'm going to say Monday, 9 AM, I know it's made absolutely 0 spoons because it doesn't start until 9 AM. At 10 AM, it is going to have made exactly 180 spoons. At 11 AM, it's going to have made twice as many. So that is going to be 360 spoons. At 12, so that would be 12 PM, it's going to have made another 180. So if I add those two together, I get 540. Now, obviously, 450 is somewhere in between, so we've got to try and work out where in between. And if you look at the link between the difference between 400 and 450, and we take away 360, you end up getting 90, which is really nice for us because 90 is halfway through. So this must have been 11:30 AM. Okay? So what I've done by here, and all I'm going to do is explain what I've done. I'm going to say counting number of spoons per hour, and I'm going to say and finding how long until 450 spoons were made. Okay? Right then, the next thing says the time at which the machines were stopped for maintenance. Well, I've done that. So I'm going to say, so the time machines stopped, or machines were stopped, is 11:30 a.m. So I've done that. It says calculate the number of forks produced between 9 a.m. and the time that the machines were stopped. So I know that I'm making 240 in an hour. So again, I'm going to do the same thing. I'm going to say 9 a.m. 0 forks were made. At 10 a.m. 240 forks have been made. At 11 a.m. another 240 have been made. So that is it is 480. Now to get to 11:30 a.m. I am going to have to add on half as many. So 240 divided by 2 is 120 in half an hour. So I'm adding on 120 onto 480. So that is 600 forks produced in that time. Okay, so I'm just going to explain where that's come from. So I'm going to say in 2.5 hours, in 2.5 hours, 600 forks were produced. Okay. Now, in terms of that, there's nothing really that I haven't mentioned. I've talked through my theories. I've put little arrows explaining what's happened. Maybe I've missed this bit here. So I'm going to say number of forks in 30 minutes, or in half an hour. Number of forks in 30 minutes. And again, maybe I've missed out this thing here, so I'll just go and explain what it is. And that was the difference between 450 spoons made and 360 spoons, I was going to say made in total there, sorry, and 360 spoons made in 2 hours. Okay then, really you need a piece of tracing paper for this. The first thing that you should do is go and plot this point here. So 2 minus 1, that means you come along the corridor to 2, so by there, and then down the stairs, up or down the stairs. In this case it's down because it's a minus 1. So 2 minus 1. So you go and plot that point, maybe a little bit too thick there, but I'm just trying to show where it is nice and clearly for the video. And then draw your crosshair there, because this automatically splits it up into 90, 180, 270 and 360 for you. Okay, the next thing to remember is if you've got your watch there or a clock, here's the hands. Which way they turn round? Turn round this way. So that way is what we call clockwise, and it says in the question to turn anti-clockwise 90 degrees, so we need to go the opposite way of that. Okay, so placing your tracing paper over the page now, trace the shape here, there, and your crosshair, and then put your pencil or pen on the actual centre, and then have that crosshair cross over on itself once. Okay, and when you have that done, your shape should look something like this. Okay, so I have mine here. Okay, the next question here says an enlargement. Now, enlargements usually do what they say on the tin, which says enlarge, but if I'm enlarging something by a scale factor of half, this means it's getting half as big. If something's half as big, you're actually getting smaller. Okay, so I'm going to say that is the same as dividing by 2. Now, the way I do this is I look at my centre here, and I find the nearest corner to that, which is this one here. So how do I get from here to here? Well, I went down 2, so this time I'm going to do half of that, which is going down 1. Okay? Now, what I could do is I could say, how do I get to this corner here? I go down 2 and across 4. So half of that would be going down 1, and then half of 4 going across 4 would be going across 2. So there. The way I prefer to do it is to say, well, this line here originally was 4 long. So in my enlargement, it must be half as big because of that scale factor, which would mean it is 2 long. Okay? And this one here is 1, 2, 3, 4, 5, 6 long. So in the enlargement, it must be 3 long. So 1, 2, 3 by there. My way doesn't work very nicely with any diagonals, however. Okay, so this one here, for instance, I can't actually measure how long that is. It goes through corners, and we don't like that. So I am going to count to this corner here. So I get to that corner by going up 1, 2, 3, 4, 5, 6, and going across 1, 2, 3, 4. So instead of going up 6 and across 4, I now need to go up 3, 1, 2, 3, and I need to go across 2, 1, 2. So by there. Okay, now it's a case of just joining up the dots with a ruler. So yours should look better than mine because I'm doing it freehand. There and there, and it's absolutely fine to have the shape inside another shape. Okay, with question 7, the big key word here is regular. Regular polygon means all sides and all angles are equal. Okay, now I would find this very hard to try and complete with the 162. So what I'm going to do is extend the line there and work out this angle here. To do that, I'm going to do 180 minus 162. Okay, so that is going to give me 18. So I know this angle is 18 degrees. The other thing you should know is that this is what we call an interior angle, and this is what we call an exterior angle. And this fact you are supposed to know. If you don't know it, you need to make sure you write it down now on a piece of paper and stick it up in your room. You're supposed to really, really know this, this fact, okay? Exterior angles equal 360 degrees. Okay? So, I have got 360 degrees that's going to go around the entire shape. I know that one of my angles is 18, so if I divide that by 18, I'll find out how many angles there were. So I'm going to pretend that 0 isn't there for now. How many 18s go into 36? The answer is 2. And then I'm going to put that 0 back, so the answer is 20. It had 20 sides. Okay. The next question here is a fair-sided dice. Now, there's two ways of doing this. There's the really, really logical way, which takes ages and ages and ages, and then I'll show you a really quick way. Okay, if I was to throw 2 dice, or to throw the same dice twice, calculate the probability that I get 4 both times. So, the first time I get it, I get 1, 2, 3, 4, 5, or 6. The second time I could throw it, I could get 1, 2, 3, 4, 5, or 6. So the scores I could get 1 and 1. I could have got a 1 then a 2. I could have got a 1 then a 3. I could have got a 1 then a 4. I could have got a 1 then a 5. Or I could have got a 1 then a 6. Okay. Alternatively, I could have got a 2 the first time. So I could have had 2 then a 1, 2 then a 2, 2 then a 3, 2 then a 4, 2 then a 5, 2 then a 6. Okay, and as you can see, it's going to take me a long time to write out all of these different solutions that I could have had. Okay, the quick way to go about this is say, right, I've got 1, 2, 3, 4, 5, 6. I've got 6 outcomes here. Okay, I've also got 6 outcomes here. Okay, so if I've got 6 outcomes the first time, then 6 outcomes again, there is going to be a total of 6 times by 6 equals 36 outcomes in total. Okay, how many of those would have been a 4 and then another 4? Well, that's only going to happen literally when I get a 4 there and a 4 here. So the answer is 1 out of 36. The other way, the quicker way than drawing this table, would have said the probability of getting a 1 getting 4 from one dice is 1 in 6, and you'd multiply that by 1 out of 6 to get a 4 again. So the answer would then be 1 out of 36. This is the really quick way, but you've got to have a lot of base knowledge, whereas this is a much longer way, but makes maybe a bit more sense. But either way is fine. Okay, then for this question, words you need to know. You need to know what this word here integer means. That just means a whole number. Okay, so it could be 2, it could be 3, it could be a million. It can't be 1.7. It can't be 2.9. Okay, it's got to be a whole number. So I'm just going to have a guess. I'm going to guess 2. So I'm going to say let x equal 2. So that would be 2 cubed minus 2 times 2. So that's going to give me 8. That's going to be 4. 8 take away 4 is 4. It's not 21. So I need to try another number. So I'm going to try 3. X equals 3. I'm going to get 2 cubed minus 2 lots of 3. I just realised I made a mistake there. That shouldn't have been a 2. It should have been a 3 because I'm trying x is 3 this time. I was just doing the same as last time. 3 cubed is 27. Take away 2 times 3, which is 6. 27 take away 6 is 21. So my answer was x equals 3. Okay? Big hint in this question when it says write down all possible solutions. Now you'd like to think that you say, right, y squared equals 49. To get rid of the squared, we are going to square root both sides. And then from y squared, you would say y equals 7 when we have y is equal to the square root of 49. But that's not true because you can also get y equals minus 7 because minus 7 times by minus 7 would be a plus 49. Okay, so you can also get its negative answer as well. The next one I would have thought you can all do very easily, so I'll just show you very quickly. X cubed times by 3x would be 3x to the power of 4, and then timesing it by the minus 5 will give me minus 5x to the power of 3. Okay then, for the last question here, first of all, I'm going to do 4, add 2 just by the side because that's pretty easy. I can do that bit straight away. That's 6. And then I'm going to do 3 quarters plus 3/8. So I'm going to add the fractions together. Now we could go and use your method of doing that, but it might be a bit of overkill here straight away. Okay, what I would do is look for the smallest denominator, this one here, and see if it goes into that, which it does in this case, or if there's a nice number that I can obviously see the pair of them go into. But as 4 goes into 8, I'm going to change that first fraction. The second fraction is going to remain the same. I'm going to change this to being something over 8. So how do I make that 4 be something over 8? Well, I double it. But to remain an equivalent fraction, if I double the bottom, then I must double the top. So that's going to give me 6 over 8. Now, altogether, that gives me 9 over 8. Okay? Now, 9 over 8 is like 9 pieces cut into, or like a whole pizza cut into 8 pieces. But I've actually got 9 of those pieces. So that means I must have 1 and 1/8 left. Okay? 1 whole and 1/8. So now I want to do 6, add 1 and 1/8, which would give me 7 and 1/8. And the question said, express your answer as a mixed number, which mine is, in its simplest form. And because 1 over something must be in its simplest form anyway, that's already done. Okay?
Okay, not the easiest question, this one, because it's requiring you to have so many background things to know here. So when it talks about this cylinder holds approximately 5 litres of liquid, you're expected to know what that is in centimetres cubed. So if you don't know that, then you're going to feel that you can't answer the question straight away. I don't actually know what 5 litres is. I know what 1 litre is, okay? And you need to learn this. So if you didn't know that 1 litre was equal to 1,000 centimetres cubed, then if I were you, I'd put a big circle around that and write, learn this fact. Okay? The real reason why is 1 milliliter is equal to 1 centimetre cubed, and there's 1,000 millilitres in a litre, so that would make it 1,000 centimetres cubed. Okay, so it says this hollow cylinder is made with an internal radius of 4 centimetres and an internal height of 10 centimetres. Carwin says the cylinder holds approximately 5 litres of liquid. By estimating pi as 3, show whether Carwin is correct or not. You must show all your working. So at first you would have thought the volume of this cylinder is impossible because you need a calculator, and this is obviously a non-calculator paper. However, you can work this out because they're telling you to estimate pi as 3, and even if they didn't, you'd still take it as 3.14. Okay? So to work out the volume, something we've done very recently is our C grade topic of the week. Volume is equal to pi r squared, which is the area of the cross section, so this thing here, times by the height. So the height of that would be 10. Okay, so we're going to say pi, which we've been told to take as 3. When it says brackets when it says r squared, we're going to change that to brackets r squared, and then times by h, so we're going to say brackets again. So the radius, although I've covered it up and it says that, was 4. The height was 10. So I've got 1 mark just for subbing into that formula and knowing the formula. So then I'm just going to do the squaring bit first. So it's going to be 3, 16, 10. And the reason why I did that was just a word called BIDMAS. So that told me to do the indices first. And now this is all just multiplying. I'm going to do 3 times 16, but I'm not a million percent sure of what the answer is. So I'm going to say 16, add 16, add 16. It's one way of doing it. That's 18 and 4. Or I could have done 16 times 3. I said that's 18. Then 1 times 3 is 3. Add the 1 is 4. So that's 48 times 10. And then 48 times 8 is 480 centimetres cubed. And the answer was absolutely miles off, which is fine. They're just doing it to test that you know this this conversion. So is he correct? No, because it's saying 5 litres. I'd say no, because 5 litres is 5,000 centimetres cubed. I think what this guy's got confused with is that he thought 5 litres was just 500 centimetres cubed, so nowhere near.
Okay then, for nth term, what I need to do is check what the numbers are going up in, but just make sure you keep checking. So, first of all I add 4, and then I add 4 again, and add 4 again, and add 4 again. Now because I'm adding 4 every time, we say that is 4n. Okay? Now I like to go and find this number in front of the 9, so to find that, I must have been going back and forth, so I'm going to take away 4, and that will leave me with 5. What sort of 5? A plus 5, so it's 4n plus 5. The next one says, Karis says that 149 is in Dewey sequence. Is Karis correct? You must explain your answer. So my sequence is 4n plus 5, and Karis is saying that 149 is in there. Okay, so it's just an equation to solve. So I'm going to take 5 from both sides, and that leaves me with 4n equals 144. And then I'm going to divide both sides by 4. So to divide by 4 without a calculator, I'm going to halve it, and then halve it again. So if I halve that, I get 72, and then if I halve that again, I get 36. But if you wanted to, you could write it as 140 and 4. Half of that is 50, half of that is 20, half of that is 2. That gives me 72. And then half of 70 is 35, half of 2 is 1, so 35 and 1 makes the 36. So the answer is yes, it's the 36 term. It's term 36. Okay, if it had been a decimal there, if it had been like 35.2, you can't get the 35.2 term. Okay, so it has to be a whole number, or what we call an integer, as your answer here. Okay. Finally, this question here is going to get continued onto the next page, so I'll just turn over to that. Okay, with pattern questions like this, it's a good idea to try and find some sort of number value. So I'm going to call this one here, I'm not going to call it, I'm going to say there's 6 pieces there. In this one here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if I stop there, I might go wrong here. I'm just looking at that and saying, oh, well, double of 6 is 12. There we go, I solved it. But that's not strictly true. If I count the next one, I've got 1, 2, 3, 4. And then we've got 1, 2, 3, 4, 5 rows. 4 times 5 would give me 20 there. So if I doubled 12, it wouldn't give me 24. So that isn't the pattern that's happening here. And then finally, I've got 1, 2, 3, 4, 5, 6. So 5 across, and then 1, 2, 3, 4, 5, 6 going down. 5 across, 6 down would give me 30 altogether. Okay, so we could maybe have a look to see how many of these are going up in. So I add 6, and then I add 8, and then I add 10. Now, some of the things that people do wrong, if you look at the next question, it says, in pattern 8, are there going to be 110 like little panes of glass? And the answer is no. And some people say, the answer that some people say is, oh, look at pattern 4, pattern 8 will be double of pattern 4. But that's not true. If you look at pattern 2, if you double the 12 there, that doesn't give 30 for the pattern 4. So we need to try and work out what's going on. Okay, so I'm going to write these numbers on the next part of the question. So in number 1 we had 6, in number 2 we had 12, in number 3 we had 20, and in number 4 we had 30. And when I was having a look at that, I said, well, I've added 6, then I've added 8, and then I've added 10. Okay? Now, the most obvious way, if you're really, really stuck, is just to carry on the pattern. So if I get to pattern 8, 5, 6, 7, 8, if it was like pattern 80, then obviously I'm not going to do this. I'm going to try and think of a different way. But I've got to try and think what I'm going up in. So 6, 8, 10. So for me, it makes sense we go add 12, then add 14, then add 16, and then add 18. Okay? That's probably what I would do to begin with if I was unsure. So 30 add 12 is 42. 42 add 14 is 56. 56 add 16, add them in 2 goes, so add the 10. 66, add the 6 is 72. And then add the 18 onto that then is going to take me up to, again, I'm going to take it in 2 stages. Add 10 is 82, add the 8 is 90. So the answer is no in pattern 8. In pattern 8, answer equals 90. Okay? Now, you could have used what we're going to use here to prove that this thing's either right or wrong. The best way to do this for me, and it's a hard question, this one, you know, this is one that I won't be gutted if you come to the class and say, oh, the quadratic nth term was hard. Yeah, it is hard. Okay? So, I'm going to just do the first couple that we had. What we do is we look at the first difference. So difference between 6 and 12, well, we've already done that, 6, 8, and 10. I then look at the second difference. And if you notice here, the second difference is equal to the same number. If they are equal to the same number, that tells me it is an n squared sequence. Okay? Now, in terms of getting the n squared sequence, what we then do is we look at the second difference. So in this case, it's 2. And you halve it. You always halve the second difference to find if you have a coefficient. So half of 2 is 1, but do we really need to write 1n squared? Could we not just leave it as n squared? And the answer is yes, just leave it as n squared. Now, what we talk about when we talk about n squared is we are talking about the square numbers. So n squared would be 1 times 1, 2 times 2, 3 times 3, and then 4 times 4. And I'm looking from how I get from 1 to 1 to 6, 4 to 12, 9 to 20, 16 to 30. And the answer is I plus 5. Then I plus 8. Then I plus 11. And then I plus 14. And again, we can see that there's another pattern going here. 5, 8, 11, 14. Now that's going up in 3. So we'd say that is plus 3n. And then I come and find the number that would go in front of the plus 5. So if I'm going up in 3s this way here, I must be coming down in 3s this way here. So this would be a plus 2, and that's the number that gets plonked on the end here. So my answer is, Val says the pattern for n contains n squared plus 3n plus 2. Painted glass, is she correct? You must justify your answer. And that is exactly right, and I have shown the method. Okay, and this question is asking about cumulative frequency. So cumulative frequency here, this means your running total. So it's a good idea that whenever you see that word cumulative frequency, you say running total next to it. So this one here, this first one, the reason why this is 0, it says the number of people who are earning less than or equal to 100 quid a week. And we're told in our first group here, it says between 100 and 200 quid. So no one's earning less than or equal to 100 quid. Okay? So that's why that's 0. The next one is 10. The next one, you'd be wrong to say 22, but you're doing the right sort of thing if you're thinking 22, because obviously when it says less than, so when it says less than 300, we're after all of these people here, between 100 and 200, and between 200 and 300. So we're after the running total. So that's going to be 10 plus 22. So that's going to give me 32. Okay? So the next one then, saying less than 400, is going to be this 32 that I've already accounted for and another 46. So 32 and 46 are going to make 78. Then I'm going to add 54 to that. Now, I'm not quite sure off the top of my head what 78 add 54 is. So by the side, I'm going to write 78, add 54. 8 add 4 is 12. 7 add 5 is 12 as well. Carry the 1 is 13. So that is 132 that's going to come here. Then I'm going to add on 18. That's number bonds. That's going to take me to 150. And then add the 10 is going to take me, well, that's 156, sorry, 150. Is going to take me to 160. And then I'm going to check in the question that says, the group frequency table shows information about the weekly wages of 160 office workers. So that 160, I know, is right. Okay. So you now need to go and draw your diagram on the next page. Okay, I can't answer these questions until you've gone and done that. So go and draw your diagram plotting 100, 210, 332, 478, and you should get some sort of graph that looks roughly like that sort of shape. So then to find your median, you would go in the middle. So you go along at 80, and then to find your interquartile range, you would go at half of what you've just gone for the median, and then the median and the lower quartile added together to find the upper quartile. Okay? So it'd be there and there. Okay, but you need to physically go and draw that first. But I can give you the formula, is interquartile range is equal to the upper quartile, take away the lower quartile, but I'll talk through what they are in the next part of the video. And you've got one of your 2 marks there just for getting that formula down. Okay, finally it says estimate the number of workers who with a weekly wage of more than 520 quid. Okay, so what we're going to look for on the x-axis on the next graph, we're going to look for 520. We're going to stop there, go up, hit our graph, and read off, and see what the difference is between what the total was and how many people are earning about 520. Okay, so I'm going to plot the points from my table from before. So I've got 0 and 100, so that's physically on the x-axis there. Then I've got 210. Now I need to work out the scale. I know this must be 20 because it's halfway between 0 and 40. And then I've gone up 20 in 10 little squares. So that tells me each little square must be worth 2. Okay, so to plot 210, that's quite easy. That must be in between the middle of 0 and 20. But the next one at 32, here's 20, here's 40. So 30 must be this line here. And then 32 would be one little square up. So 32 would be by there. Then 478, so I'm not going to count up from 40, I'm going to start at 80 and count back in 2. So there's 80, come back 2, would put me on 78, so that would put me by there. 500 and 132, so I'm going to skip up to 120, that would be 130, one little sort of half square up, because that would be 140, and then 132, one little square up from there again, so about there. And then 600 and 150, so that's going to be by there. And then 700 and 160 would be by here. I then use a ruler. Some teachers will say to do this freehand, but you could lose a mark if you do your freehand wrong, whereas if you use a ruler, you won't lose any marks at all. I'll literally just do a dot-to-dot drawing. So there to there, to there, to here, and like that. Okay? I'm then going to write out the formula that you should have written on the previous page, which is IQR is equal to UQ take away LQ. That will get you a mark for doing that. I'm then going to write above this, I'm going to say CF, the cumulative frequency is 160. The median is half of that, so that's 80. The lower quartile is half of that again, because it's 1/4 of the cumulative frequency, which is 40. The upper quartile is 3/4 of the cumulative frequency. So there's 2 options here. You could either do 40 times 3, or you could do the median, which is half, add a quarter, because a half add a quarter is 3/4. So 80 add 40 is 120, whichever one works for you. I now need to draw a line at 40 until I hit my graph, which is by there. I then need to come down and read off what that value is. So coming down, I make that 310. And I'm going to say by here, LQ equals 310. It's not the LQ is 40, but that's the line where we go across from 40. The upper quartile, so I'm going to draw a line coming across from 120 until I hit my graph. And I'm going to come down and read off what it is. And I make that 480. So I'm going to say UQ is equal to 480. Don't worry if you have slightly different answers to me. As long as they're in the same ballpark, that's fine. So you get marks for reading off your graph properly, as long as your graph is reasonably correct. It depends if you did it freehand or with a ruler. So now I'm going to say that is 480, take away 310, 0 take away 0, 8 take away 1, 4 take away 3. So my answer is 170. Okay then, so final bit of the question. Looking for 520, coming up from here at 520, staying as close as I can to that line. There we go. And then hitting the graph and coming off and reading where it is. So off my graph, I make that just shy of 140. I make it 1 under. The one little square is worth 2. So I'd make this at 138. Now, 138 is not the answer, okay? The answer to that is, it says how many more people, or how many people earn more than 520 quid. So all of that is these people here. So I'm trying to work out how many people are from here to here. So from 138 to 160, I need to work out how many people there are between that number. So I need to do 160 take away 138, which is going to give me 220. So the answer is 22 people earn more than £520. Okay? Okay, then to answer a question like this one for 14a, we're looking for a pair of numbers that add together to give this number, and they times together to give this number. Okay, so I'm going to write that down by here. Times to minus 15 and add to plus 2. Okay, and before I go too much further, I'm going to write here that a positive times a positive is equal to a positive times a negative equals a negative times a positive equals a negative as well, and a negative times by a negative is equal to a positive. Okay, and I always used to write that down in my exams. So if I'm timesing to get a negative here, then the only options I could have had is having one of each sign, so a plus and a minus. So I'm going to start off by saying plus, minus, plus, minus, plus, minus, plus, minus. The reason why I've written down a few is just so I can guess a few numbers. It really doesn't matter how many you write down to begin with. If you get there first time, brilliant, but it's probably a bit of luck. So I'm thinking of a pair of numbers that times to 15, ignoring the signs now, absolutely. So a pair of numbers that times to 15. Well, let's start with 1 and 15. Okay, now this is telling me to do 1 take away 15. That clearly isn't plus 2, so I know that one isn't the combination I want. Even if I have 15 and 1 the other way around, I then get 14, so that's still not plus 2. What about 3 and 5? Plus 3 times minus 5 would give me minus 15, but that would give me minus 2. I want plus 2, so that's not it. But all I need to do is switch over my numbers, so it's going to be plus 5 minus 3. So then my brackets would be x plus 5 and x minus 3 is equal to 0. Now, for the next bit, it's saying that this thing here, and then the sign that's missing that should go in between here that we don't write when we're talking algebra, is a time sign. Okay? So this is saying this times by this equals 0. Now, the only way we can get anything to give an answer 0 when we times two numbers together is that one of those things is 0. So we'd say either x plus 5 equals 0 or x minus 3 equals 0. Okay? And then it's just solving a normal equation. Take away 5 from each side. 0 take away 5 gives me x equals minus 5. And add 3 to each side, x equals normal 3. Okay? If you can only get up to this bit here, you'd still get 2 of these 3 marks. This is only worth 1 mark, this bit here and here. The next one's a little bit more easy to solve. We're going to do the numbers times each other, so 3 times 4, which is 12. We're going to do the letters, so a cubed times by a to the power of 6 would give me a to the power of 9. And then we're going to do b to the power of 5 times b, which would be b to the power of 6.
Okay, this question looks really, really, really horrible, but it's not that bad, honestly, I swear. It's not that bad. There's easy marks to pick up out of the 8, okay? Out of the 8, I'd expect everyone to easily pick up 2 marks here, okay? It says, this rectangle, A, which is 2x and 3y, and perimeter is 94, and so x plus 6 and y plus 4 is a perimeter of 56, okay? Now, what you need to do here, you need to think about what we already know about the information we're given. This isn't a hard marks pickup. Perimeter is 94 centimetres. What is perimeter? That's what you should be asking yourself. What do I know about perimeter? If worst case scenario comes up, you just say perimeter is all the sides added together, because it's like the distance around the shape. It's like me starting here and doing 1 lap of the shape. And there it is. I've got the mark. It's going to be 3y plus 2x plus another 3y plus another 2x is equal to 94. Okay, that really wasn't that bad. And it's about having to ask yourself, what do these terms mean? What can I get out of this? I know we're a long way past the staples, but that doesn't mean you cannot pick up marks here. So that's one of our 8 marks. I'm now going to simplify that to make it a bit better. I prefer getting the x's in front, just alphabetically. You don't have to, though. So I've got 2x and another 2x. So that's going to give me 4x plus 6y is equal to 94. Okay? So that's that one dealt with. So dealing with this one now, the next one says a perimeter of 56. So I'm going to start in the same corner, I'm going to add, and I'm going to go around like that again. Okay? So my first line is y plus 4. Then I'm going to add x plus 6. So far I've gone from here to here. So now I need to go back with another y plus 4 and another x plus 6. And that has given me a perimeter of 56 centimetres. How many y's have I got? How many x's have I got? So x's, 1, 2. I've got 2 x's. How many y's have I got? 1, 2, plus 2 y's. How many numbers have I got? Well, I've got 4 and 6, that makes 10. Add another 4 and another 6, that makes another 10. So add 20 is equal to 56. Okay? Now I can't quite solve these at the moment, but before I try and solve them, I'll tell you what they are. They are simultaneous equations because we've got x's and we've got y's. So I've got this plus 20 here that I don't like being on that side, so I'm going to take that over to the other side, or I'm going to say take 20 off each side, whichever way you prefer. Okay, I'm going to get rid of that for now, but whichever way you prefer. And I'm going to get the statement 2x plus 2y is equal to, so taking off 20 would give me 36. Okay, so this is equation 1, this is equation 2. I've got to either get the x's the same or the y's the same. Now, if I look at the one with the smaller x's or the smaller y's, does that fit into that or that fit into that? And the answer is yes in both cases. That's not very usual that happens. I'm going to go with the smallest number, so I'm going to get the x's the same. To do that, I'm going to times that one by 2. I'm just going to leave that one as it is. I'm going to times it by 1. Okay, so 4 times 1 would just be 4x. I'll call this 3 and 4 as well, okay? So 4x plus 6y is equal to 94. Nothing's changed there. But the one underneath, I'm going to have 4x plus 4y, if I can write y, 4y is equal to double of 36. So 30 and 6, double of 30 is 60, double of 6 is 12, 60 and 12 makes 72. I am now going to subtract these equations. So subtracting these equations gives me 4x take away 4x is nothing. 6y take away 4y is 2y. And then 94 take away 72 is going to give me a 2 and another 2. So 2y is equal to 22. And then I will divide both sides by 2, or I'll take the 2 over and divide by, to get 11. So y is equal to 11, but we are not finished there. Okay, we have got another bit to do, which is we need to sub in my value of y as 11, and then we need to solve it. Okay, so I'm going to sub that into 2. Sub y equals 11 in 2. So you're going to get 2x plus 2 brackets 11, when we sub in, we just change them for open brackets, is equal to 36. So that gives me 2y plus 22 is equal to 36. I'm now going to take 22 from each side. That leaves me with 2x is equal to 14. And then I'm going to divide both sides by 2. And it leaves me with x equals 7. Now, whatever you do, do not finish there. Go back, read the question. Have we actually answered what it said? It said, use an algebraic method to calculate the area of each rectangle. I have found the sides. Okay, so for rectangle A, this is, I'm going to zoom in, I'm going to work up by here actually for these ones. We have just found that x is 7, so this is 2 lots of 7, which would be equal to 14. And this is 3 lots of 11, which would be equal to 33. So to work out the area, I need to do 33 times by 11. Okay. From there, whatever method you prefer, I'm going to use Chinese multiplication. If you don't know what I'm doing, please just use a method that you're happy with. So 33 and not 11, sorry, it's 14, isn't it? 33 and 14. So then 3 times 1 would be 3. So I write 0 up there, 3 down there. Then 12, then 3 again, and then 12 again. So I'm going to get 2, 6, 4. So the area of this one is 462 centimetres squared. And then working on this one here, so if x was 7, this is going to be 7 plus 6, which is 13. And this was going to be 11 plus 4, which is 15. So this one here would be 15 times by 13. So again, I might split this. I might partition this one. 15 times 10 and 15 times 3, both reasonable numbers. That's 150. That's 45. So add them together will give me 195. So my answer is 195 centimeters squared.
Okay then, for questions like these on question 16, the first thing that I've noticed before I've even read the question is there's a different thing on the y-axis, which isn't frequency, it's frequency density. So you should know a formula to go with that straight away. That formula is frequency density is equal to frequency divided by class width. What I could do is I could rearrange that formula to be frequency density, so that divide by class width, to get rid of that I'd times both sides by class width. So frequency density times by class width would be equal to frequency. So this question says, calculate how many telephone calls were made to the computer helpline during the Friday evening. So that is how many just means frequency. So it's the blue formula that I've written that I want to use. So reading off the frequency density here, 1, its class width goes from 0 to 10, so that is a width of 10. So for this bar here, I do 1 times by 10, which is 10. For the next bar, the frequency density is 6, and its class width is also 10. So I'm going to do 6 times by 10, which is 60. And then I'm going to carry on doing that for the remaining bars. So I'm going to get 10 times 10, which would be 100. I'm going to get 4 times 10, which is 40. I'm going to get 2 times 10, which is 20. But then very finally, this last bar here, this has got a class width of 20, and its frequency density is 1, so it'll be 1 times 20, which is also 20. And then I'm going to add all of these numbers together. Okay, so I'm looking for number bonds particularly. I've got 60 and 40, which make 100. Add this 100 will put me on 200, 220, 240, 250 in total. So I'm going to say total equals 250. Okay, the next question says, estimate a percentage of the phone calls that lasted longer than 3/4 of an hour. Okay, that's quite a tricky question. If you don't get this one, this isn't a problem, but I will still go through this one. I'll be expecting to see most of these start. 3/4 of an hour is how long in minutes? The answer to that is 45 minutes. So I'm looking for where 45 is on my length of telephone call, and I can see it right by here, 45. So I'm going to cut that bar there. So I want to know how many people took longer than that. I know there's 20 people in here. I know this bar here, I know that was originally 20, and I've just cut it into 2 10s by cutting it in half. So the answer is there are 30 people who took longer than 45 minutes out of a total of 250 people. Now, that is not a percentage. It says, calculate that as a percentage. That is just a fraction. So I want to try and make that, turn it into something over 100. Now, this sounds like a weird idea, but I know that if I times that by 4, I'm going to get it to being over 1,000. Now, that nearly is 100. It's 100, but 10 times bigger. So I'm going to times this by 4 as well, and that's 120. And then I'm going to divide both by 10. So dividing by 10 and dividing by 10 here is going to give me 12 out of 100, which is 12%. I'm going to skip part C. It's quite tricky. We're more than happy to go with you through it in class if you want to see how to do it. Not a problem, but it's not one of the ones I'll be looking at in the exam saying, oh, we've all got to get that. If we get anything from the last question, we'll be really, really, really pleased. And there's question 17 here that, again, I think we're capable of doing. Okay? So we start off this one by stating what it is. First of all, I'm going to leave one line to say x equals 0.34646646 ... Now, because there are 2 dots by there, I'm going to times this by 100 because that's got 2 zeros. I'm going to line up the equals and the decimal point together. By timesing this by 100, 2 of these numbers are going to shift over here, so that 34 will become 34. Then it's followed by 6, then a 4, 6, 4, 6, 4, 6, ... This question is all doable providing you line up the decimal points nice and neat and the equals nice and neat. It'll make everything much, much, much easier. I'm then going to take away the 2 numbers. So 100x take away x is 99x. I'm then going to line up the decimal point here, and then 6 take away 6 cancels, 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 loads of cancels, until we get 6 take away 3, which is 3, 4 take away nothing, which is 4, 3 take away nothing, which is 3. Okay? Then I'm going to divide both sides by 99 and get 34.3 over 99, but there's a big issue with what I've got. That has got a decimal in a fraction. You cannot have a decimal in a fraction, so all I'm going to do is times top and bottom by the same number to turn it into an equivalent fraction, which is 343 over 990.